Okay, so welcome to exam 2 review. And for intermediate algebra. And I don't know which, oh, it's recording this. Gosh, I forgot I'm not already sharing screen. So let me share screen. That would be nice. So here is our review. Well, at least the blank document that I'm going to be writing on. Here is our actual review. If you want to find this, you're just going to go into our course, which is online math resources for students. And from here, you will go into intermediate algebra by clicking on the little dashboard icon right there. And then you will click on test review materials or test materials. I can't remember which one it says. Test review materials. There it is. And so I open it up. And we are working on exam 2. Well, once we click on my math lab reviews, we are working on exam 2, test 2, review version B. We are recording this right now. We are working on the solution guide right now. So as soon as we are finished, I will upload the solution guide. And then my partner in crime on here, Ms. Vudak, once she gets the link to the recording, she will link that in on our document. So this is the version that we are working with right now. And it's the same version that I showed you just a second ago right here. All right, so with that being said, I'm going to get rid of this and let us focus in on our review. You have 20 questions for this. This will cover in exam 2, systems of inequalities, and factoring and long division. So all of that is covered within this video. Okay. So here we go. So the first question is, we've got this point 4, 4, and we've got this system 4x minus 2y equal to 8, negative 3x plus 4y equal to 4. And we want to know, is that a solution? So how do we check that? What do? How do I check if a point is a solution to the system?
So you just plug in the points.
That's right. Plug it into both, plug it into the first one and see if it gives you the answer 8. If it does, then plug it into the second one, see if it gives us the answer 4. If it works in both of these, it's a solution. If I plug into the top one and I do not get 8, then it's not a solution. Or if I plug into the bottom one and do not get 4, then it is not a solution. The moment it messes up for one of these, no bueno. No, not a solution. So let's plug into the top one. Remember that points are made up of x, then y. So we've got 4 times 4 minus 2 times 4 equal to 8. So what is 4 times 4?
16.
16. Minus 2 times 4.
Negative 8.
Well, the negative is there, but this will just be 8. 2 times 4 is just 8.
Oh, sorry.
It's okay. So what is 16 minus 8?
Oh, 8.
So that checks out. So far, this is a solution. Let's check the next one. Negative 3 times 4 plus 4 times 4. Is that 4? So what's negative 3 times 4?
Negative 12.
What's 4 times 4?
16.
So the question is negative 12 plus 16 4?
Yes.
Yeah. So it works. So is this a solution?
Yes.
Yes. Solution. So in your exam, you would just come over and you would check yes. Question number 2 is the same idea. You've got this point 1/5 comma negative 2. And we got this system 5x plus 9y equal to negative 17. 10x equals 4y plus 7. So again, how do I check to see if it's a solution?
You plug in.
Plug in. And anyone feel free to answer. We don't have to rely completely on Catherine. So we're going to plug in. So we're going to take 5 times 1/5. I know many of you are probably freaking out. Ah, it's a fraction. That's okay. We got calculator. Because the 1/5 is the x. We'll plug negative 2 in for y. So that gives us 9 times negative 2 equal to negative 17. All right. So let's do some multiplying. Again, you all have a calculator. Use it. So I'm going to bring up my calculator, my TI-84 calculator. And we're going to take 5 times 1/5. So my calculator's coming up. And remember that I have shown you guys how to put fractions into the TI calculator. If you're using some other calculator, let me know and I can try and maybe tell you how to put fractions in it. So in the TI-84, you hit alpha, y equals, and there's your fraction key. Okay. So we're taking 5 times alpha y equals 1/5. And what do we get?
1.
1. See, fractions aren't scary. We got a calculator. Fractions are no big deal. So we know that 5 times 1/5 is 1. What's 9 times negative 2?
Negative 18.
Negative 8. So the question is 1 plus negative 18 negative 17?
Yes.
Yes. Negative 17 equals negative 17. So far, this is a solution. So let's check the next guy. We're going to take 10 times 1/5 equal to 4 times negative 2 plus 7. Again, you go to the calculator, just multiply that out. What is 10 times 1/5?
2.
2. And then we've got 4 times negative 2
Negative 8.
plus 7. So what is negative 8 plus 7?
Negative 1.
Negative 1.
Yeah, negative 1. Does this match? Does this make sense?
No.
Nope. So that's no good. So is this a solution?
No.
No.
No, not a solution, period. So in your exam, you'll go back and you'll say no. There you go. There's the first 2 problems. Number 3, a little bit of graphing on this one. A little bit of graphing. What's that?
I have a question.
Sure.
On the exam, are we gonna have one where we need to take a picture of the graph that we make ourselves, like you did on one of the, I think one of the homework assignments?
Well, let's keep going through and find out.
Okay.
So here we've got this system. X plus y equal to 5. X minus 3y equal to 9. And they want you to graph and then select your answer. So remember that when we solve systems, there were 3 types of answers you could have. You could have one solution, and that means our lines intersected. They hit each other. You could have infinite solutions where your lines lie on top of each other. So when you graph it, it only looks like one line. That's what choice B was. So if you graph and it lies on top of itself, that means that's the infinite solution. So if you select B, you are selecting an infinite solution. And then the other one is if you graph them and they look parallel, then that's a no solution because they'll never hit each other. So these were the 3 answers, possible answers we could have. One solution where they intersect, infinite solutions because they lay on top of each other, or no solution because they're parallel. So let's graph this, okay, and talk through how that's going to work. So remember, this is all in my math lab. So it has a graphing system. 7, 8, 9. Doing my best to keep this as even as possible. 5, 6, 7, 8. I'm doing a 9 by 9. There are 9 marks here, 9 on each side. And I'm counting by ones. Your graph will be counting by ones because it's already set up. 8, 9. Okay. So remember, in my math lab, once you click on the graph, a toolbar will show up at the bottom. And in that toolbar, it has a button that says clear. And then there is kind of like a select tool button that looks like an arrow, like a cursor arrow. Then there's like a dot. Then there is a line tool that has 2 dots on it. And then they have like a quadratic tool. Then over here, there's 2 buttons on top of each other, one with a solid line in it, one with a dotted line in it. And then over on the other side, I believe there was a paint bucket over here, something along these lines. Okay. So you are graphing a line. These are lines. So what you're going to do is you're going to come down here. Once you click on the graph, you're going to come down and select the line tool, and you're going to plot 2 points. Okay. And graph your line. Now, back in module 1, I taught you how to graph in this kind of form. What form are these equations in?
Standard?
What form?
Is it standard?
They are in standard. And do you remember how I graphed in standard?
Nope.
Nope. Well, I'll remind you, it's what I called the BAM method. Or in other words, you're finding the X and Y intercepts. So take this equation right here, X plus Y equal to 5. If I want to find the X intercept, who do we not care about?
Why?
The Y, right? So you go, bam, gone. What's left?
5. X is 5.
X equals 5. There, you just found the x-intercept. And remember that x-intercepts look like a number, comma, 0. So this is one of the points you're going to plot for this line, 5, comma, 0. If I want the y-intercept, who do we not care about?
The X.
The x. So you go, bam. What's left?
5. Y is 5.
Y equals 5. And there's your y-intercept. And remember, y-intercepts look like a number, comma, 0. So our y-intercept is 0, comma, 5. Remember, I just told you a minute ago, once you select the line tool, it takes 2 points to graph. So notice here are my 2 points. So in order to graph this line, I'm going to use 5, comma, 0 and 0, comma, 5. So I'm going to go out here to 5, comma, 0. Well, actually mimicking what's going on. I click on my graph. I click on the line, and then I come up here and I put a dot at 5, comma, 0. And remember that once I move my cursor away after I click there, my line is formed. I just got to click the second point. So I'll go to 0, comma, 5. And I'm going to click my second point. And my line becomes solid once you click that second point. Give me a moment to try and be as accurate as possible with what I've got. So once I click that second point, that line is set. Okay. And now we just need to graph the second line. Again, it's in standard form. So we can do the quick cover-up method. So if I want the x-intercept, who goes away?
Y.
What's left?
X is 9.
Okay. So we now know that we're going to plot the point 9, comma, 0. When I want the y-intercept, who do we not care about?
X.
What's left?
Negative 3y equals 9.
And how do we solve for the y?
Divide by negative 3.
Divide by that negative 3. So y is equal to?
Negative 3.
So there's our second point, which would be 0, negative 3. And so we come up here and we're going to graph these 2 points to make our line. So we come up here and we're going to click on the graph. We got our toolbar. We're going to click the line and I'm going to graph 9, 0 first. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to come down. Once I move away, so I did my click, my line is there. I got to do my second click, which will be 0, negative 3, 0, negative 3, and my line will solidify. Give me just a moment to get this guy as best as I can. There we go. So if we look at this, where is it that our lines are going to cross?
6, negative 1.
6, negative 1. Right there. And that's the answer we want. So you will select A because it's a 1 solution. And the point is 6, negative 1. And that's what the graph will look like. Are you doing that graph on your own? No, you're using MyMathLab. MyMathLab has a built-in graphing system. Now, that's one way to do it. Notice I showed you a lot of work, okay? Remember, you have a graphing calculator, right? So we can go in and we could actually put this in our graphing calculator. But in order to use our graphing calculator, these are in standard form. What form do they have to be in to use the graphing calculator?
Slope intercept form.
Slope intercept. So that means we need to take these real quick and do a quick change. So how do I get this in slope intercept, which is y equals mx plus b?
You have to isolate y, so you would have to subtract x.
Good. So we're going to subtract x from both sides. And we got y equals negative x plus 5. Or you can write 5 minus x. Either one is correct. Okay. I always like to put the x variable first. So there's one of the equations I'm going to put in my graphing calculator. And then now we're going to take the other equation, x minus 3y equal to 9. And how do I get y by itself this time?
You're gonna have to subtract x, then divide by -3.
You got it. So we'll get negative 3y equal to negative x plus 9. And then just as you said, we're going to divide by 3. Now, some math teachers will just say, put a line over here and put -3 on the bottom. I'm not that kind of math teacher. I make you separate it out. Because it really is two fractions that are going on over here. There's the fraction with the x, and then there's a fraction with the 9. So in the end, we get, what's -1 divided by a -3?
Positive 1/3.
Positive 1/3. What's 9 divided by a -3?
-3.
There's the second equation I will put in. So now that I have these, I'm going to go to my graphing calculator. And I'm going to go up to y equals. Hold on, let me check something, make sure I'm in, because I also use this calculator for calculus. So I want to make sure I'm in the correct mode. So we're going to put in our y equals. So one of them was negative x plus 5. The other one was 1/3. So I'll hit alpha y equals 1/3 x minus 3. Go to graph. And there you can see that 6, -1 happening. And in class, for my courses, I showed you how you can verify this a couple different ways. We could hit second graph and look to see when the y values are the same. So if I scroll down, oh, there it is. Y values are the same. That's the intersection point. When the y values are the same, that's your intersection. Or you can go out to graph, and if you hit second trace and bring up calculate, you can go right down to number 5 for intersection. So I scroll down, and this is going to ask you 3 questions. So it's asking you where the intersection is on the blue line. So I'm going to scroll to the right till I get to the intersection as close as possible. So I think it's right about there. Then it says, where is it on the second one? Well, it's right about there. Then it says guess. And it's right about there. So basically, once I scroll to the intersection, I just hit enter 3 times. So there's the third time, and there's the intersection that we just talked about. Now, the other thing is, if you are using the graphing calculator, we found these points here for each of my equations. I can use my graphing calculator to help me find other points. Because remember, in order to plot the blue line, I just need 2 dots. I need 2 points. So if I go back to my table, I have lots of points that are listed right here. I could plot using 0, 5. I could plot using 1, 4. I could plot using 2, 3. So you could use your graphing calculator, go to the table and just find 2 points without having to do any work. And then the same thing for my second equation. I could use the point 0, -3. I don't really want to graph fractions, but oh, right here. I could use the point 3, -2. If I scroll down, oh, I could use the point 6, -1 to help me graph the second line. So I could use my graphing calculator to help me find 2 points that I could use to graph. What I'm trying to say is you don't always have to do all this work. Okay, there are faster methods, more efficient methods. But in the end, you have to make a graph and you got to find the intersection. Any questions on number 3? So I showed you 2 different methods there. You can graph it using intercepts because it was in standard form, or you can convert it to slope intercepts and use your calculator and have it help you graph. All right, number 4, unless there are any questions. Cool. All right, wrong one. There we go. Number 4. So we kind of just talked about what number 4 is asking. I want to know which graph below shows no solution.
C.
Which graph below shows no solution?
D.
D. How did you know it was D?
Because the lines don't intersect. So.
Correct. Because when a system shows a no solution, it means the 2 lines are parallel. Means the 2 lines are parallel. And D has parallel lines. C, that's what it looks like for a 1 solution, which is what we just did on number 3. And the same thing for B, that's a 1 solution. And A is what it looks like for the infinite because it's just 1 line. These 2 lines lie on top of each other. So number 5 and number 6 are just reiterating what we talked about. So number 5 wants to know which graph shows the solution of 1, -6 only. One, -6. Which one is it? A, B, C, or D?
D.
It is D again. Because that's an infinite. That's a no solution. This one looks like they're plotting -6, 0. So that's definitely not the solution. So it is D because this is over at the 1 and down at -6 there. So D is the only one with the point graphed correctly. Number 6, which one of these shows the infinite solution? A, B, C, or D?
A.
A, good job. So the infinite solution, when you graph it, it looks like 1 line graphed. Any questions about 4, 5, and 6?
No.
Okay, moving on. So 7 and 8 you're solving the systems. So when you're doing 7 and an 8, I'm encouraging you not to do graphing, because graphing is like, graphing is kind of hard because you have to be very, very accurate. Now we do have graphing calculators that can help us, but these problems are better suited for using some of those algebraic methods like elimination and substitution. That's really what 7 and 8, we as professors are encouraging you to do. So on number 7, we've got x equals 3y plus 4. And then we got another equation that is 2x minus 6y equals 8. So again, we could graph that, but the algebra will be a little bit better for this. Okay. So which algebra method, substitution or elimination, would be best for this one?
Substitution.
Absolutely. I would do substitution. Why?
Because
Because
one of them is already solved.
one of the variables is already solved. What variable do we already know?
X.
We already know what x is. X is 3y plus 4. I would definitely do substitution. Because all we have to do is take this 3y plus 4, is put it right in there for x. Exchange it out. So if we plug in, I get 2 times 3y plus 4 minus 6y equal to 8. So what are we going to do now?
Distribute the 2.
Distribute the 2. All right. So that's going to give us a 6y plus 2 times 4 is 8 minus 6y equal to 8. Now what?
Cancel out whatever is the same.
Yeah.
So 6y minus the 6y. That leaves you with 8 equals 8.
Okay. So we combined like terms and my variable went away and we got 8 equals 8. What does that mean? When our variables go away and we're left with 2 numbers and they are the same.
It's an infinite solution.
This is an infinite solution. So remember, when your variables cancel out and they are the same number, that's an infinite. If these were different numbers, then we would have said no solution. So in number 7, since it's infinite, which answer would we select? A, B, or C?
B.
You would select B because B is the infinite answer. Any questions on number 7? All right, number 8. We've got this system of 4x plus y equal to 15 and x minus 3y equal to 7. Just to let you know, substitution is the easiest method for number 7, but you could have done elimination on this. There's nothing wrong with that. You could have done that. Okay. So down here, number 8, here's the system. What do you think is going to be our easiest method for this?
Elimination.
I would do elimination on this one. Absolutely. But do not get me wrong. You could do substitution. We could get the y by itself or the x by itself. But I think elimination is a little bit faster. So let's do elimination. So with elimination, you have a lot of choices you got to make. Remember, elimination, we got to pick a variable we want to get rid of, and we got to get the same number in front of it where 1 is positive and 1 is negative. So Jada, pick a variable, x or y?
X.
All right. So we're going to get rid of x. I would have chosen y. It's a little bit easier, but that's fine. It's neither here nor there. So we're going to get rid of x. And I need this to be the same number in front. So I've got a 4 and a 1. What can I turn 4 and 1 into to be the same number?
4.
4. Yeah. Or I could have turned them into 8. Or I could turn them into 12. Any factor of 4 is going to work for this. Now, I need one of these to be a negative. And again, it doesn't matter. These are choices you have to make. Which one do you want to be negative? Anybody? Top or bottom?
Bottom.
Okay, good. I like the bottom too. So since these two match already, I'm not going to change my top equation. I'm not going to do anything to it. But notice these two do not match. So that means we need to multiply this equation by some number that will give me -4. So what times x gives me -4x?
-4.
So this entire bottom equation is going to get multiplied by -4. So we already know -4 times x is -4x. We knew that. We're going to take -4 times -3y, which what does that give us?
Positive 12y.
Positive 12y equal to, and we're going to take -4 times the 7. What does that give us?
-28.
And now we're actually ready for elimination. What do we do now with elimination?
Pretty much add everything up.
Add everything up, add down. So what's 4x plus a -4x?
0.
0. And we knew that was going to happen because we wanted to eliminate x. That's what Jada said. Let's get rid of our x's. Okay. When we add up the y's, what's 1y plus 12y?
13y.
Boom. And then when we add 15 with -28, what does that give us?
-3.
Not -3.
-13.
-13. So how do I get y by itself?
Divide by 13.
We're going to divide by 13, divide by 13. What does y equal?
-1.
Perfect. Now that we know what y is, so if you're thinking about this, that means our solution is going to be something, comma, -1. How do I figure out what that x value is?
You input the y value that you just found into the equation that you have not touched.
And actually, you can put it into either one of these. It doesn't really matter. Take your answer and plug it back into one of the originals. Don't plug it in down here. Plug it back into one of the main ones. Okay. And it doesn't matter which one. So pick one. Someone tell me, you want the top equation or the bottom equation?
Bottom.
What was that? I got mixed signals.
Oh, the bottom equation, because we just used it for the other one, right?
Oh, yeah, we can. I mean, we used it for the other one, but we can plug into the top one. It doesn't really matter, but you said bottom, so let's plug into the bottom. So we got x minus 3 times our y value, which is -1, equal to 7. What's a -3 times a -1?
Positive.
So we got x plus 3 equal to 7. Now what?
Subtract 3.
Minus 3. And we now know that x
It's
is
4.
equal to 4. And we now know that the solution is 4 comma negative 1. So when we come back out to number 8, which one are we going to select? A, B, or C?
A.
A, and then over in the blank, you'll put parenthesis 4 comma negative 1. Parenthesis. Any questions about number 7 and 8? Okay. Oh, then they're going to be mean to us and they're going to give us a word problem for number 9 and 10.
I hate
But
these.
that's okay because we talked about word problems. At least I know I did with my courses, and I'm sure other professors do as well too. So remember that the word problems kind of come at you in one of two forms. They're either translation problems, where they're telling you mathematical symbols and words, like 3 times x plus 7 equals 8. Or they're giving you standard form equations, where you have totals. If you know a total, then you have standard form. So if we look at number 9, it says one number is 9 less than a second number. And then there's another sentence that says 4 times the first is 12 more than 5 times the second. They want to know what are the two numbers. Okay. So what kind of word problem is this? Is this a translation or is this standard form?
Standard form.
This is standard form. Are you sure?
I think so because it's giving you two separate equations.
Well, if it's giving you two separate equations, what do you notice about all these words? Do you see mathematical terminology in here?
Sort of, kind of.
Say it again.
Sort of, kind of.
Sort of, kind of.
Yeah. So like 4 times.
Ah, that's a mathematical word, times, right?
Yeah. More than 5 times.
Ah, more than 5 times. What operation is more than?
Addition.
Addition. Less than. What word is secretly in mathematics?
The equal sign.
Equals. One number equals. There is nothing but mathematical terminology here. This is a translation. It's not a standard form.
I lied. Don't listen to me, guys. It's a translation.
It's okay. That's why we talk about it. There's nothing wrong. We make mistakes. I make mistakes. It's okay. So what we want to do is translate. So I have our two sentences here, and each one of these sentences is an equation. So let's translate. So up here, that's not an H, that's a number sign. It says one number is. What do we want to call this? How does that translate?
That could be X.
Ah, X what?
So you can do one number as the first number. You can either do X or F. So you understand that.
Ah, good. I like that you're using F. You know what? I'm going to change that up. Let's use F for the first number, right?
Yeah.
Man, someone must have taught you good.
Yeah, I think his name is Mr. Armstrong.
Yeah, what a loser.
I think
like Mr. Armstrong. All right. I like F. And I was writing up here, F is all about our first number. Okay, so F, I like that. What is the is part?
An equal sign.
Equals. All right, now over here it says, I'm gonna kind of circle that. That's an equals for us. 9 less than a second number. What was less than?
Subtraction.
Subtraction. Okay. Now, what do we want to call a second number?
You can use S.
Oh, so good. I like S for second. I'm just going to kind of put that notation over here so I remember. So how does this look then if that's going to be my S? If this is, so because subtraction is fickle, you have to have a certain order for it. So are we going to write 9 minus S? Or should it be S minus 9? What do you think?
It should be S minus 9.
Oh my gosh, I'm doing my job. How did you know that it's really S minus 9?
Because the other way around, it would look like the S is negative, right?
Well, I mean, it's okay if S looks like it's negative, but why is it specifically this?
Because if you do it in the other format, it'll give you the wrong answer.
Well, I mean, you'll get an answer. Do not get me wrong. If we had it 9 minus S, we would get an answer. We would only know it's wrong once we submit in the end. But remember in class, and I always warn my students about this, less than. When you see this word less than as an operation of subtraction, remember that it is written backwards. Less than is written backwards. So this is the first number minus this is the second number. It's written in reverse. So that's why it is S minus 9. This less than, it wrote it backwards. They're trying to throw you off. Because I will have students that will say 9 minus S. And I would be like, no, less thans are written backwards. So there's one of our equations. All right, let's jump to the next one. So it says 4 times the first is, what does that look like?
4F,
Boom. What is the is part again?
an equal sign.
The equal sign. And you knew that it was times. I always like to highlight that, put my little dot. So it's definitely 4 times the first, which was our F. So 4 times F is, almost forgot my equal sign. Now this one says 12 more than 5 times the second. What's going on there?
5S plus 12.
Boom. 5S plus 12. Because more than is all about addition. And you got multiplication there. And remember that we called the second number S. Now, I will let you know that in this one, if you wrote 12 plus 5S, that is perfectly a-okay as well too. Even though technically more than means just like the less than, this is written backwards. The reason why I can switch it on addition is because it doesn't matter how you add. 2 plus 3 is the same thing as 3 plus 2. But in subtraction, it matters because 2 minus 3 is not the same as 3 minus 2. So if you did write this as 12 plus 5S, you're fine. It's the less than one you have to be careful of. All right, so besides the point, we now have our 2 equations. what's going to be the easiest way to solve this now?
Substitution.
I would do substitution. So we got our two equations. I'm just going to rewrite them down here with one on top of the other. And I would run substitution. It's going to be the easiest. Because we already know what F is. And all we got to do is plug that back into F. So we're going to have 4 times S minus 9 equals 5S plus 12. All right, so what are we going to do to solve?
Distribute the 4.
Yes. So that will give us 4S minus 36 equal to 5S plus 12. Now what?
Combine like terms. Remove the-
Can't combine like terms yet.
Oh, well, move the. How would I do it? Hold on, I'm confused.
Like I can't put these together. I
No,
can't
no,
say
no,
this
no.
is,
That's not what I meant. I meant to,
Oh.
I subtracted the 12 from the 5S
Okay.
and moved that on over.
so
And then
so let's do that. So we subtracted this. So we moved the 12 over here. So that will give us 4S minus 48 equal to 5S.
and then I moved the 4S over to the 5S.
How do you move 4S over here to the 5S?
I subtracted it.
Okay. And that's one way to do it. I would have moved the 5 over to the 4 and then added the 36 over to the other side, but it doesn't matter. We're all going to get to the same answer. So we got negative 48 equal to 5 minus 4. It's just 1S. And if you really want to divide by 1, you can, but you don't have to. In fact, you don't even have to write the 1 if you don't want to, because now you already know what the second number is. Second number was
Negative 48.
negative 48. How do I get the first number?
You input that into the equation that's solved, or not already solved, but already isolated.
Yeah, we can put it right back into that. That would be the easiest, but I could put it back into either one of these two. It doesn't really matter. But I'm going to do what you just told me to do. I'm going to go back into this guy. So we already know. So the first number we're working on, but we already know that the second number is negative 48. So we got that piece. So to get the first number, we're just going to plug back in. F equals negative 48 minus 9. So what is F?
Negative 57.
And there we go. There are the two numbers. Any questions about number 9? The big thing is you got to realize that it's just a translation. So be careful when you translate, especially with the words less than. This thing is written backwards. Once you got the equations, it's all over but the crying, because you guys are substitution elimination pros. Let's look at number 10, mixture problems. A mixture problem. So number 10 says, find how many quarts of 5% butter fat milk and 1% butter fat milk should be mixed to yield 100 quarts of 3% butter fat milk. Okay. So what are we dealing with here? Is this a translation, or are they giving us totals, which tells us it's standard form?
I don't know. Um, mm,
What is this? Is this translation or standard form? Give you a hint. Do you see any mathematical operation words like times, plus, minus, less than, more than, quotient, product? Do you see any of those words?
No.
No. This is probably standard form, and it is. They give us a total. Who's the total on here?
100 quarts of 3%.
100 quarts of 3%. That's a total. If you have a total, they're giving you standard form. Okay. So let's talk about these equations real quick. So let me do some writing real quick. We've got 5% butter, fat, milk. And we got 1% butter, fat, milk. And we got this 3% butter, fat, milk. And you already know that we are working with a total of 100 quarts of 3% butter, fat, milk. Just writing down some pertinent information. So here's what we know. We've got 5% plus 1% is going to yield us 3%. Okay. See, that's standard form. AX plus BY equals C. So let's talk equations. One of our equations has to equal
100.
100. The other equation, remember, is a combination of these two. We want 3% of 100. But remember, we don't use percentages in mathematics. What do we use?
Fraction.
Uh-huh. What do we use?
Fraction.
We can. I don't want to work with
Decimals.
fractions.
Sorry, decimals.
Decimals. Yes. What is 3% as a decimal?
0.03.
0.03. I like it. What is 1% as a decimal?
0.01.
And 5%?
0.05.
So these are the values we're going to use to represent those. So this other total is the 3% times the 100. That's how we get the other total, because it's a mixture. So let's talk about what's going on. So what kind of labels do we want to use? Because we've got 5% and we've got 1%.
We can use X and Y because if we use the letters that coordinate with 5 and 1, the O for 1 will resemble 0.
That is true. That is true, because the O could look, we could misinterpret it as a 0. So we can use X and Y. So I'm going to call the 5%, let's just call that X. Let's just call this guy Y. Okay. So we know that X is all about 5%, Y is all about 1%. Hey, you kind of see an equation up there? What do you think that equation is going to look like?
It's gonna look like the second one on the bottom.
Say it again.
Gonna look like the second one on the bottom. So the one
Yeah,
that you-
right?
Yeah.
So this guy looks like 0.05x, and I wrote that too low, but that's all right. We'll just curve it up. Plus 0.01y. Notice this is all about my percentages. Percentage, a percentage, a percentage. But I've used all of my information now. I've used the 100, I've used the 3%, I've used the 1%, I've used the 5%. What do you remember this equation is going to be if I've used all of my numbers and they're not left? What would this remaining equation look like?
Well, if you take into account that it was asking about percentages and quarts, you're gonna realize that the quarts, the variables are x and y, so it would be x plus y equals 100.
You got it. This one is all about my percentages. I call this my percentage equation because it's percents, percents, percents. This one, just as you said, is all about quarts. I have so many quarts here plus so many quarts here, better be 100 quarts. Now we have our equations. And now we can start to do our mathematics. What would be the easiest method to use for this?
Elimination.
I would do elimination. Okay. So I'm going to rewrite my equations because I want to actually multiply this out. 0.05 x plus 0.01 y equal to, and 100 times 3% is
Is
3.
three.
Okay. So we're going to do elimination. So we need to pick a variable. Let's go, Catherine, pick a variable. X or Y?
X.
X. So we're going to get rid of our X's. You ladies are all about getting rid of your X's. All right. So we're going to get rid of X. So that means I need to get the same number in front. What number can I transform 1 and 0.5 into?
0.05.
0.05. That's what I would just make them. Okay. And I need one of these to be positive, one of them to be negative. Which one's which?
The top.
Yeah, let's make the top one negative. Because if you notice, these two right here already match. So let's just leave that bottom one alone. And let's manipulate the top one. So what times my 1 will give me negative 0.05? So
Wait,
what times x will give me negative 0.05x? What do we got to multiply by?
Oh, 0.05.
Negative 0.05.
Oh, oops.
It's got to be negative because we want it to be negative. So all we're going to do is distribute. So negative 0.05x is negative 0.05x. We knew that was going to happen. Negative 0.05 times y is negative 0.05y. And negative 0.05 times 100 is negative 5. So what do we do now?
Eliminate.
Eliminate. We add down. So the x's go away. Your plan worked. If I take negative 0.05y plus 0.01y, what do we get?
Negative 0.04.
And -5 plus 3.
-2.
How do I get y by itself?
Divide by -0.04.
So y is equal to what?
50.
50.
50?
Yes.
Okay. So remember, y is about 1%. So the 5% butter, fat milk, 1% butter, fat milk. We know the 1% now. It is 50 quarts. How do I get the 5%?
You input y into one of the original equations.
That's right. Let's take the y value that we know here of 50 and plug it into one of these two. Which one are we going to plug into?
The top
One-
one.
Yeah, I plug into the top one. That's the easiest. So x plus 50 equals 100. What does x equal?
50.
50. Because you're going to just subtract 50 from both sides. So it's a 50-50 split. There were 50 quarts of 5% butterfat milk and 50 quarts of 1% butterfat milk. Any questions on number 10? Okie dokie, artichokes. And I believe those are your only two word problems. There aren't any others. That's it. So 9 and 10, halfway through. All right, number 11 and number 12. This is after we get done with number 12, that will end our systems section. And then all we have left is long division and factoring, which is super important for us. So we got 3x plus 4y greater than -8. And they want us to graph this. Okay. All right. Kind of looking at this, trying to figure out what I want to go out to. Give me just a moment. Oh, okay, so it's not too big. Okay. Again, this will all be done in my math lab, so you do not have to create your own graph like what you're probably doing right now. So here's my graph. I just did a 5 by 5. So it goes out to +5, up to +5, -5, and -5. All right, what form is this in?
Standard.
It's standard. But if I do standard form right away, if I look at my x-intercept, I'm going to get a decimal. So I probably don't want to do the cover-up method on this. What you want to do is you want to convert this to slope-intercept. And we'll have our calculator help us out. Okay. So let's convert this to slope-intercept because that will be much easier for us to handle. So what are we going to do first?
Subtract the 3 on both
All right.
sides.
-3x minus 3x. That will give us 4y greater than, and I always like to put my x first, -3x minus 8. Now what?
Divide those four.
All right, so we're gonna divide each number by 4. So we got y greater than, that's gonna stay because that does not reduce any, negative 3 over 4x. And then right here, what is negative 8 divided by 4?
Two.
Negative 2. So there's our equation that we want to graph. So just like what we talked about before, I'm going to go into my graphing calculator. And I'm going to go ahead and get what this equation looks like. So we've got a negative 3/4. So alpha of y equals 3 over 4. Hit my x and then minus 2. So there's my line. I need this on my page. So how can I use this to help me out?
Go to second graph and grab 2 points from the table.
Yeah, there we go. Let's do that. So second graph, let's look for 2 points. Oh, there's one. 4, negative 5. So I'm going to write that point down. And then I'm just going to scroll up. Let's look for another one. Let's see here. Oh, there we go. 0, 2. Sorry, 0, negative 2. And if you kept scrolling up, another possible point that I would use, maybe negative 4, 1. And again, you have more graph than what I drew. There's another one, negative 8, 4 that you could use. So you just need 2 of those. All right. So let's go ahead and let's get this graphed real quick. Now, remember that when you click, we get our nice little toolbar. But because this is an inequality, we got a couple more things we need to use on the toolbar than what we did before. So you got the clear button. You've got your selector tool. You've got your line tool, or actually your dot, your point. You got your line tool. There are some other tools there you know about. We got our 2 buttons where one is a solid line, one is a dotted. And then after that, I believe we have our paint bucket. Okay, it's a horrible paint bucket, but it's there. So when you're doing 11 and 12, you are going to be using the line tool. You're going to have to worry about whether it's solid or dotted, and you're going to have to worry about the paint bucket. Okay. So first things first. Is this line going to be solid or dotted?
Dotted,
Dotted.
How did you know?
because it's not equal to.
There we go. Because of this, you need to choose the dotted line. Okay. So I'm going to select the line. I'm going to select the dotted. And then now I'm going to graph my 2 points. 4, negative 5. And as soon as I move away, that was my first click. As soon as I move away, I've got this dotted line that's following my cursor. And I'm going to graph my second point. Negative 2 or 0, negative 2. I'm going to draw in my line. And it's going to look like this. Because once I click that second point, it becomes a dotted line. Okay. Now, the only other thing you got to worry about is the paint bucket. So again, we got our great graphing tool. And my graphing tool can paint my screen. If I just go back into y equals and I scroll over all the way to the left and I highlight this and I press enter. I'm going to go down to my line button and I'm going to scroll up. That's the symbol if you have greater than or equal to. That's the symbol for less than or equal to. So if I go back real quick and look, we have the greater than button. So in my calculator, I want the triangle that looks like that. So in my calculator, I'm going to go back one. And I'm going to hit OK. And now if I go and graph, now I know where to put my paint bucket. So we come back in here. We just graphed our line. We come down, we select the paint bucket. And do I push it above or do I click below?
Above.
Yeah, you come up here with your cursor after selecting the paint bucket and click anywhere up here. As soon as you click, your screen will turn yellow above your line. That's the answer they're looking for. Any questions about number 11?
No.
Okay. Let's do number 12, where all you're doing in number 12 is you're graphing two of them. All right. So we've got y less than 4x minus 1. We've got y less than or equal to x plus 4. Let me get my graph up here. And I'm going to do another 5 by 5. Again, all of this is on MyMathLab. So you don't have to draw your own graphs. You'll be using the MyMathLab graph, just like in your homework, other than that one lab question. You are not going to do anything like the lab. All of your graphing is inside the MyMathLab. Got it. All right. Okay. So again, I'm going to have my calculator do a lot of help for me. And again, as soon as you click on that graph, your little toolbar shows up. Clear your selector tool, your point, your line. There are some others, but we don't care about them. And you got your solid line, your dotted line, and then our paint bucket. Okay. So the first one I'm going to deal with is y less than 4x minus 1. Best part is on number 12, these are ready to go for your calculator. Okay. But before I jump to my calculator, I have the less than symbol. So what does that mean about my line?
Dotted.
It should be dotted. So make sure that when we draw this line, we choose dotted. And because it is a less than symbol, what kind of triangle will I be looking for? The top triangle or the bottom triangle?
Bottom.
So when we go in, we'll want the bottom triangle for it. When I have y less than or equal to x plus 4. I have less than or equal to. So what kind of line will we want?
Solid.
Solid.
Solid. I have less than or equal to. What kind of triangle will we want? The top or the bottom?
Bottom.
The bottom. All right. And then all I need my calculator to help me do is get 2 points and then look where the shading is. That's really what I need my calculator to help me do. Get 2 points for this guy, 2 points for that guy, and go from there. All right, so let's come in here. Let's go to y equals. Let's clear all this out. I'm going to put in 4x minus 1. There's what it looks like. Let's get some points. So being very nice to me and knowing that I only did a graph from -5 to +5, what are 2 easy points I can use?
0, negative
1.
Okay, 0, -1,
1, 3.
and 1, 3 sound great. All right. And I'm going to come and I'm going to change. Well, yeah, I'm going to come down here. So what I'm going to do is I'm going to turn this guy off for a moment. I'm going to scroll down and we're going to put in the other equation, x plus 4. So there's what that one looks like. Go to my table. Be nice to me, please. And what are 2 easy points for that one?
-4, 0, and -3, 1.
Okay. So I'm going to go ahead and I'm going to get these graphed first. And then we'll worry about the shading. Shading is always the last piece. So we're going to graph 0, -1, and 1, 3. We're going to make sure that we choose dotted. So we click on our graph, our toolbar comes up, click on the line tool, click on the dot. Come up, 0, -1. My dotted line is following my cursor. Click my second point, 1, 3, and connect the dots. Oh, and it's dotted. Silly Mr. Armstrong. So I'm going to take my lovely little white out here and dot it. There we go. Easy fix. And then now we're going to graph the second line. So I'm going to push my line tool. I'm going to push the solid. And I'm going to graph -4, 0. And I'm going to graph -3, 1. It's probably a little too high. And this one will stay dotted or solid. So there's our line. I really made that one too long. All right, so the last part that we have to do now is we have to figure out where's the shading. Okay. So I'm going to go back to my calculator. I'm going to turn this guy back on and I'm going to go over and manipulate. I want the bottom triangle for both of these. There it is. So that one's good now. Scroll down. Enter. Bottom triangle. And now I hit graph. So I'm looking to where the shading is together. That's where we want to put the paint bucket. So where is it that red and blue overlap and it looks purple? So let's come back to our picture. I click on the paint bucket. Do I click in region 1, region 2, or region 3?
3.
Three.
Yes, it's right over here. This is that region 3 that I said. Here was region 1, there's no shading. There's only the red in that region 2 I talked about, and there's region 3. Obviously, there's a region 4 up there, but I didn't make my graph long enough. So that region 4 actually kind of starts right up in here. But I click my paint bucket and I click anywhere in there. And that's what they're after. Any questions about number 12? So there are 3 actual graphing problems. It's all done in my math lab. And there are 2 word problems. And that right there wraps up systems. From here on out, this is all about factoring and long division. So there is only one long division problem. So we got 6x to the third minus 3x squared minus 14. I think there's supposed to be an x with that plus 3. And that is being divided by 2x minus 1. Yeah, that negative 14 there should have an x by it. All right, so we are doing long division. Which one of these parentheses goes under the division symbol?
First one.
The first one. And then the 2x minus 1 obviously has to go out in front. So we perform long division. So who is it that we're going to focus in on first? What term do we want to get rid of?
6x cubed.
So we want to get rid of the 6x cubed first. And who are we always going to use to help us get rid of the 6x cubed?
2x.
2x.
The 2x. This is the one that's going to be in charge to help us get rid of terms that are underneath here. So we're going to think to ourselves, what times 2x will give us 6x cubed? And that's what's going to go up here above our division. So what times 2x gives us 6x cubed?
3x squared.
Yay. So we're going to take this 3x squared and we're going to multiply our 2x minus 1. So when we distribute through, that gives us the 6x cubed. No surprise there. But what's 3x squared times negative 1?
Negative 3x squared.
Okay. And then what do we do in long division?
Distribute the negative and then add them together.
Absolutely. You can distribute the negative through here and then add down, or I don't really distribute it. That's not my style. But again, there's nothing wrong with that. Distribute the negative through and add down. I just know that this is subtracting down. So these two are going to cancel, which we knew was going to happen. And then over here, you have negative 3x squared, that's the top, minus another negative 3x squared. I always just think about it as subtracting down. So what happens with a negative by a negative?
A positive.
So what's negative 3x squared plus 3x squared?
0.
So all that goes away. And then we play Tetris. Because we bring everybody else down. So who are we going to focus in on now?
Negative 14x.
The negative 14x. And we're going to repeat the process. What times 2x gives us negative 14x?
Negative 7.
Yes. And we're going to multiply negative 7 times 2x minus 1. So we already know that that's a negative 14x. What's negative 7 times a negative 1?
7.
And then what do we do now?
Cross out
Subtract
the negative.
down. So again, the x's cancel. We made sure we engineered it so that would happen. And over here, this is 3 minus 7. What is 3 minus 7?
Negative 4.
Negative 4. And we stop our division because there's nothing times 2x that will give us negative 4. So this, remember, is what we call the quotient. And this is what we call the remainder. And how do we write remainders?
You just add it into the answer that you got. So if it's a negative number, you'll put it as minus the remainder over the quotient.
There we go. So minus the remainder, because in this case, it's negative, or you could say plus a negative, either way. And you take that remainder and you put it over what you were dividing by. So that is one way to write it. Remember, this is what we call the quotient. This is what we call the remainder. Or, again, as we just said, this is A-OK as well. Because this is a negative, we can move that to the front, and it's minus 4 over 2x minus 1. Either one of those is A-OK. Any questions on number 13?
No.
That is your only long division problem. Everything else on this from 14 through 20 is factoring. So let's see how good these factoring skills are. So number 14, the directions say exactly what's going on. It's all about a GCF. So we've got this 6x to the 4th minus 48x to the 3rd plus 30x squared. Oops, we don't need that. So remember, there are two kinds of GCFs. What are they? What are the kinds of GCFs?
Are you talking about the questions I asked us?
Yes, there are two questions that I had you guys have, which are leading to what GCFs. So let's just go with that. What are the two questions you should ask yourself about a GCF?
Is there a number that divides all the numbers, and do all terms have a common variable?
There we go. Because the two kinds of GCFs that exist, there are number GCFs and there are variable GCFs. Okay, so to figure out the number, is there a number that divides all of these?
Yeah, 6x squared.
6. Let's just talk about the number. Let's not worry about the variable yet.
Oops,
So
sorry.
6, it's okay, divides all of these. That's the biggest number. Okay, because remember, we're looking for the GCF. That's the greatest common factor. Yes, 2 divides all of these. And yes, 3 divides all of these, but 6 is the biggest one. And that's what we want. GCF, greatest common factor. So there's a number. And then do all of these have variables? Well, actually, do all of them have the same variable?
Yes.
Yes. So we're going to pull out an X. And remember that the most amount of X's you can pull out is whatever the lowest power is. So our lowest power is 2. So you are absolutely right in the beginning when you said we're going to pull out a 6x squared. So all we do is we write down what's left. Remember that all these numbers are divisible by 6. So what is 6 divided by 6?
1.
So there's a 1. And then we are pulling out 2 X's from each of these. So there are 4 X's here. I'm pulling out 2. How many are left?
2.
So my first term, when I pull the GCF out of this, is 1x squared. So I move to my next one. What is negative 48 divided by 6?
-8.
There are 3 X's. I'm pulling out 2.
Leaves you with 1x.
Leaves us with 1x. So when I take the GCF out of the next term, this is what's left, negative 8x. Okay. What is 30 divided by 6?
5.
There are 2 X's. I'm taking 2 away. What's left?
None.
Nothing. And there you go. That is the answer for number 14.
We wouldn't put them in like, oh, okay. Sorry, forget it.
It's just about a GCF.
Would it
Nothing
ever
else.
Okay.
would it ever make us have to factor out like the x squared that's inside the parentheses or no?
So try and continue to factor this? No.
Mhm.
Again, all this question says is GCF. That's all at once. Okay?
Okay. Mhm.
All right. So number 15 is all about factoring by grouping. We got this AC plus 6A minus 3C minus 18. Okay. So remember with factoring by grouping, there are 3 steps. The first step is an easy one. What do?
You put parentheses around the first 2 not the very, you know what I mean.
The first 2 terms
Yeah. And the last 2 terms.
there you go. There's step 1. Now what do? I
Factor
think
it
I said there were 3 steps. It's actually 4 steps. That's the first step, putting parentheses around it. And then now what do? Sorry, I cut you off.
It's okay. You factor each of the terms you group together.
Yeah. Now it's all about GCFs. What's the GCF in the first parenthesis? What's going to come out?
A.
A. And what does that leave us with?
C and 6.
C plus 6.
Oh, yeah.
Now remember with grouping that we're going to pull some GCF out of here. And what should it leave behind?
it, for the second term, for the parentheses that you put, it should be the same on the inside as the first one.
Correct. So whatever we pull out of this, it has to leave us with a C plus 6. These two parentheses should match for for grouping to work. So if you think about it, then what times C will get us back to a -3C?
-3.
So that's the GCF that should come out of this, because -3 divided by -3 is 1, and there's a 1 there. -18 divided by a -3 is a +6. See, it matches. And now it's all over but the crying. Now you just got to tell me, what are our two parentheses?
Two parentheses, are you going to take the two terms that are outside of each of the terms be factored? So that would be a minus 3. And then the second term would be the C plus 6 because it's a duplicate.
Yeah. So my two parentheses, one of them becomes the GCFs, the a minus 3. The other one is the duplicate. And there it is. Factored according to grouping. 16. So 16 and 17 are very similar to each other. These are factoring trinomials. And now there are lots of ways to factor trinomials. You can factor them according to guess and check. Some professors teach guess and check. I do not. You can factor them according to what I call the AC method. Okay? And I play the X games. You can factor them using what I call the box method, which is like a Punnett square. And all that method is about GCFs and playing what I call the X games. Or you could factor it doing what we call slide and divide. So lots of different methods. I'm going to show two for this one. I'm going to show the AC method. And I'm going to show slide and divide. Okay. So let's do the AC method first, and then I'll talk slide and divide. So the AC method I talk about, the first thing I have you do is I have you tell me the A, B, and C's. So what are the A, B, C's to this?
1, 2, -48.
1, 2, -48. Good. And then we're going to play the X games. And in my X games, remember that in the top, we're going to put a number, and that's the A times C, hence why I call it the AC method. And then down below, we're going to put the B. So what is 1 times -48?
-48.
And then down here, we're going to put the 2. And so what we're after, we're looking for two values. And these two values, the reason why I call this the X games, because it's a game, we got to find two numbers that will multiply to the top, but add to the bottom. So in order to help us find these two numbers, we're going to focus in on this number right there, 48. And you're going to give me the factors of 48. These are going to be the numbers that help us figure out what's going to go in here. So what times what gives me 48?
6 and 8.
6 and 8. But I also know that 1 and 48 work. What else?
2 and 24.
2 and 24. And I'm going to get to the 6 and the 8. I just like to go in order. What else? 3 and how much?
16.
3 and 16.
Yeah, 3 and 16. Okay.
4
4
and
and 12.
12.
12.
And then now the 6 and the 8. I write out all my factors. Okay. So somewhere there's a combination of numbers that when I add them, they will give me 2. Now, please know that you can put negatives in here. So for instance, let's just do 1 and 48 real quick to remind ourselves how's this work. So if I take 1 plus 48, is that 2?
No.
Is 1? No.
No.
1 plus 48 is 49. That's nowhere near 2. So what if I said, well, what if I made the 1 negative? If I take negative 1 plus 48, is that 2?
No.
No. Okay, well, what if the 48 was negative? So 1 plus a negative 48, is that 2?
No.
No. Well, what if they both were negative? Negative 1 plus a negative 48, is that 2?
No.
So we know the numbers can't be 1 and 48. So somewhere in here, you can get a 2 by adding. How? How can I get a 2? By adding.
-6 plus 8.
There you go. So our 2 special numbers are -6 and 8. So there we played the X games because -6 times 8 is -48 and -6 plus 8 is 2. And now we're going to take and you're going to set up grouping like what we did in 15. When you do the AC method, it is all about grouping in the end. So you're going to keep the beginning and the end the same. The beginning and the end stay the same. In the middle go the 2 numbers we found. -6x plus 8x. See, it's grouping. We got 4 terms, just like what we had in number 15. And so we do grouping. Parentheses. And what's going to come out of my first parenthesis?
X.
That will leave us with what?
X minus 6.
And again, in grouping, whatever we pull out of here has to leave us with x minus 6. So what's coming out?
8.
A positive 8. So in the end, our factored form is what?
X plus 8 and X minus 6.
Good. And these can be in any order too. You could have x minus 6 and then x plus 8. And that's the same thing up here in number 15. We could have had a c plus 6, a minus 3. So there we go. There's the AC method. Slide and divide to show that one real quick. Slide and divide. And I wrote 17, and that's okay. I'm going to need that anyway. Slide, put that off to the side. 16 again, just with a different version. So with slide and divide, what's going to happen is we're going to take our first digit here and we're going to multiply it by the last one. We're going to slide. So we're going to slide the A down and multiply the C. And again, that's not going to change anything for us. So it's still the same. Then you're going to play the X games. Okay? So either way, you're not getting out of my X games. And we already know what the answer is. So we don't have to do anything new here. because that's A times C. This is your B. We already know that this is going to be -6 and 8. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. This is the slide and divide. Now, here's where things get different from where we did before. So in here, we set up grouping. But in slide and divide, it's like you're kind of going to go straight to the answer. So you set up 2 parentheses, and you put in X, and then all you do in here is put the 2 values you just found from the X games. -6 plus 8. Lo and behold, there's our answer. Now, you're probably thinking, well, Mr. Armstrong, we didn't do any divide, and that is true. When your A is 1, in slide and divide, really, you don't do the divide step. You just do the slide. In number 17, I'll show you the divide step. Okay, but there we go. There is slide and divide. So let's do 17, and let's start with slide and divide. So 17, we got 3x squared minus 14x plus 15. So let's do slide and divide on this one. And then the second method I will do on this is the box method. I don't know why I just put a B. Hold on. Copying this down. I'm making mistakes. Okay. So we're going to take our first number and we're going to slide it over by multiplying. So that's going to give us x squared minus 14x plus 45. And now we play our x games. What is our ABC?
A is 1, -14 is B, and 45 is C.
Cool beans. All right. So I'm not getting rid of that. I'm just fixing some things real quick. So if we do our X games, A times C goes on top. That's 45. B goes on the bottom, which is -14. So we got to figure out our 2 numbers. So everything's going to be based on the factors of 45. So what are the factors of 45? What times what gives me 45?
1, 45.
1 and 45. 2 does not work, but 3 does. 3 and what?
15.
Okay. 4 does not work, but 5 does.
And 9.
And that's it. These are the factors of 45. So how can I use addition to get a -14?
-5 and -9.
There you go. There's our numbers. Because -5 times a -9 is a positive 45. And a -5 and a -9, when added together, give us -14. And so in slide and divide, it says write our parentheses with X's, and then we put in our numbers. -5, -9. Now, because our value was actually 3 this time, here you're going to see the divide step. Once you do this, you're going to take your values you just found and divide them by 3. We didn't do this before in step number 16 because 6 divided by 1 is just 6. 8 divided by 1 is just 8. That's why we didn't have to do it before. So let's do some reducing. 5 over 3 does not reduce. But what is 9 divided by 3?
This is 3, right?
Yep. Now, because this doesn't reduce, again, we're going to do another slide. All we're going to do is take this digit, slide it back in front of the X. So in the end, this factors to 3x minus 5, x minus 3. That's the full slide and divide method. So once you find your two numbers, you will then have to divide them by a. If it reduces, great. If it does not reduce, take the denominator, slide it back in front of x. Slide. This is the divide. Hence, slide and divide. All right, I'm going to do 17 one more time, but this time I'm going to show the box method, the one that looks like a Punnett square. Okay. So the box method starts out just like all the other ones, just like the AC. We're going to play the X games. So 3, negative 14, 15. This is A times C, which is 45. This is your B, which is negative 14. We know that this is a negative 5 and a negative 9. Because when we look at the factors of 45, you got 1 and 45, 3 and 15, 5 and 9. This is the box method. So here's where the box method differs from everybody. You're going to draw a Punnett square or a box. The beginning and the end go in the top left, bottom right. So this is going to be 3x squared. This is going to be my 15. And the bottom left and the top right boxes go what we found from the X games. Negative 5x, negative 9x. And it doesn't matter which one goes where. Does not matter. So there's the setup. All you're going to do now is pull out GCFs. But this is the one catch with the box method. You have to be careful on this problem right here. When you have a minus followed by a plus in the polynomial, be careful. Because in this, when you are doing the second column and the second row, you must pull out a negative GCF. Otherwise, it will not factor correctly. This is the only kind of exception rule that you have to be careful of. Other than that, when they are the same sign, then the GCF is that sign when they are different signs then the GCF is negative. So looking at these boxes, this is the exception case. So when I look at these two, what's the GCF that's going to come out of here? What do these two have in common? Actually, I'm sorry. When it's different signs for the GCF, it remains positive unless it's the exception case. So that's where you got to be careful. So what's the GCF? What do these two boxes have in common?
X.
X. So we pull that out. What do these two boxes have in common?
3.
They're divisible by 3, but because this is that exception case, it's not a positive 3 we pull out. It has to be a negative 3. All right, so we look in these two rows. What do these two boxes have in common?
3 and X.
3 and an X. What do these two boxes have in common?
5.
And because this is that exception case, the negative 5. And now you know what your two parentheses are. X minus 3, 3x minus 5. Same answer. Not a lot of people choose the box method because of the exception case, and that you got to remember some other rules. So there you kind of seen all the methods that I teach. You've seen slide and divide twice, which is a good method. You've seen the AC method, which is a lot of what textbooks usually do. And then you have seen the box method. I have not seen a textbook yet talk about the Punnett square method. So there you go. Moving past that. When it comes to your exam, we as professors, we don't care how you factor as long as you can factor, as long as you can get to that end. All right, so 18, you are factoring a difference of squares. So when factoring the difference of squares, you can treat this just like a trinomial, because the only thing that's happening in here is you're missing the middle. So if I rewrote this like a trinomial, it looks like this. So you could go back and do guess and check. You could go back and do the AC method. You can go back and do the box method. You can do slide and divide on this because it is a trinomial in disguise. Or there's a faster way to do this, which is what I call the square root method, which is what a lot of professors teach you. What you're going to do is you're going to take the square root of the first term, and you're going to take the square root of the second term. And these are going to be your answers that we will put into parentheses, because a difference of a squares factors like this: a plus b, a minus b. So when you take the square root of the first term, that's going to tell you what your a is. When you take the square root of the second term, that's going to tell you what your b is. And then all you will do is fill in. So what is my first term?
5.
No, my first term is the square root of
Sorry, yes.
25c
25.
squared. I know what you're getting to. You're jumping ahead of me. So the square root of 25c squared, which is equal to our a value, which is what?
5C.
5c. And that looks like it's probably going to confuse people. Let me move that stuff. Back to that. So that's going to be 5c that we put in there once it dries. What's my second term? What's the second term up there? 144. Yes, you guys are correct. 144. What's the square root of 144? 12. Yes, you guys are so good. So that's the b term. And the 5c is our a that goes in our parentheses. So what do the parentheses look like now? What minus what and what plus what? Come on, we're almost done. The hard problems are all over now. What?
5c minus 12 and 5c plus 12.
So good. I love it. There you go. And now it's factored. And again, it doesn't matter the order. I could have 5c plus 12, 5c minus 12. Same thing. There's number 18. 19 and 20. These are all about factoring cubics. Factoring cubic functions. One of them is a sum of cubes. One of them is a difference of cubes. So if you look at this guy, obviously you can see this is the sum. This is the difference. So the only way to factor cubics is a lot like what we just did. And it's formula based. It is formula based. I'm going to go ahead and write down both of these. There we go. Okay. So this one is the sum of cubes. So remember that if you have the sum of cubes, it factors just like this. Gosh darn it. This is why we don't write in pen. Pen is the devil. Because when I mess up, I got to fix it. And I know I shouldn't write in pen, but I want my answer keys to live forever. So I'm going to put a b cubed here in a second. They factored with a plus b. And then a second parenthesis of a squared minus ab plus b squared. So that's how a sum of cubes factors. The difference of cubes, which is number 20, factors like so. A cubed minus b cubed equals a minus b, and then a second parenthesis of a squared plus ab plus b squared. Notice these two look almost alike. The only difference is where the plus and the minus go. It's the only difference between these two. And factoring these is just like what we did on number 18. This time you're gonna, instead of take the square root, you're gonna take the cube root of the first term. And that's gonna tell us A. And then you'll take the cube root of the second term. And that's gonna tell us the B. And all we'll do is fill in our parentheses. So who's our first term?
What, 8?
Say it again.
8?
8x cubed. So what is the cube root of 8x cubed?
2x.
2x. So that is our A. Who is the second term?
125y cubed.
All right, so we're gonna take the cube root of 125y cubed. So what is that gonna give us?
Would that be 5y?
It is gonna be 5y. So there's our B. So all we're gonna do now is plug in. So this first parenthesis is A plus B. So what does that look like?
2x plus 5y.
Okay. Now, the second parenthesis, be careful. So this says we need to square A. So what is 2x squared?
4x squared.
4x squared minus. Now this says take the A and the B and multiply them. So what is 2x times 5y?
10xy.
Plus. Now this says take the B and square it. So what's 5y squared?
25y squared.
And you are now factored. You just got to make sure that you remember the formula. 20 is going to work the same way, except it's just a slightly different formula. Any questions about number 19? Okay. So we're going to take the cube root of the first term. Who's the first term?
1?
Well, it's a little bit more than that. It's 1c
1.
cubed. So what is the cube root of 1c cubed?
1c.
1c, or we just call it c. Who's the second term? So that's our A.
125.
We're going to take the cube root of 125, which we already know the answer to because of 19, which is what?
5.
5. That's our B. All we need to do now, fill in. So this is A minus B.
C minus 5.
Perfect. So then it says A squared. So what do we get when we square the first term?
C squared.
Then it's a plus. Multiply the A and the B. So what do I get when I multiply these two?
5c.
5c. Plus, then it says square the B. So 5 was my B and I need to square it. And what do I get?
25.
You have now factored the cubic. And that, my algebra, intermediate algebra friends, is it. Are there any questions over these 20 questions?
Can you, what's the difference between like the difference in food
Jada, you're fading in the background on me.
Is this better?
Yes.
Okay. For the last two questions,
Mhm.
the difference between the two formulas, like how do you know which question to use each one for?
So right in here, this sign from the beginning tells me what it is. This is a sum.
Okay.
This sign right there tells me that it is a difference. So that's why on this, because this is a sum, that's why I use this formula, because this is the sum of cubics formula.
Okay.
And then because this one was the difference, that's why I use the difference on this guy. So you just got to look at what's going on between them. If it's an addition sign, you're going to do the sum. If it's a subtraction sign, you're going to do the difference. Good question.
Okay.
Any other questions?
Oh yeah, and I couldn't find the recording from last week. I was trying to look for it to go back over it before the exam, and I couldn't find it. So where would that be? Because I looked in like this class for Canvas, and then I went to previous recordings and I didn't see anything.
All right, hold on. So that last question for this video, do not worry about. That's specific to my class. So I'm going to go ahead and stop the video here. Thanks for stopping by.